Let's continue with our examples and look at some antiderivatives that are going to involve trig functions. Here we have the antiderivative of 3 secant x tangent x minus 5 cosecant squared x dx. There is no need to rewrite this integrand because we do have antiderivative rules both for secant x tangent x and for cosecant squared of x. The 3 will remain as our coefficient. Think back to the rules we just talked about. Antiderivative of secant of x tangent of x is secant of x minus, now we keep the 5 as our coefficient. Antiderivative of cosecant squared of x is negative cotangent x. And don't forget our constant of integration. We can then rewrite this very easily. As we've seen before, please do take a moment to take the derivative of your answer, and you should notice you get the integrand back again. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. So you can be assured that you're getting these correct. This one will require us to rewrite it. And sometimes you have to be a little creative because you only have so many rules that you know. Therefore, you need to take what you're given and turn it into something that matches up with those rules. So in this one, we have 2 cotangent of x minus 3 sine squared of x all over sine of x dx. If we were to bring that sine of x up to the numerator to join the cotangent of x, it would turn into antiderivative of 2 cotangent of x. When we bring sine up, remember that becomes cosecant of x. And we do have a rule for cotangent cosecant. Then we'd have minus 3 sine squared of x over sine of x. We can cancel one of the signs. And of course, we do have an antiderivative rule for sine of x. The 2 remains. Antiderivative of cotangent of x, cosecant of x, is negative cosecant x. I'm going to put the negative in front of the 2. Antiderivative of sine is negative cosine. Don't forget your constant of integration. Our final answer then is negative 2 cosecant of x plus 3 cosine of x plus c. Once again, you can check your answer by taking the derivative. You should get this integrand back again. Now, of course, this also presupposes that you did that rewriting from the beginning correctly. Here we have antiderivative of tangent squared of x plus cotangent squared of x plus 4. Well, we do not have any rules for the antiderivative of tangent squared or cotangent squared. So this is a case in which we're going to have to use our Pythagorean identities in order to write it first. Tangent squared is equal to secant squared of x minus 1. Cotangent squared is equal to cosecant squared of x minus 1. And then we have the plus 4. Let's go ahead and simplify that a little bit before we actually do our antiderivative. Negative 1 minus 1 plus 4, of course, is plus 2. Saves us a little bit of work. Notice how we're keeping the differential there as we rewrite this. Now we have rules for these. Antiderivative of secant squared of x is tangent of x. Antiderivative of cosecant squared of x is negative cotangent x. Antiderivative of 2 would be 2x. Once again, take the derivative of that. You'll notice you get your integrand back again. And we have one last example. Antiderivative of 4 minus 3 over 1 plus x squared dx. Going term by term, antiderivative of 4 is simply 4x. For the second part, this is where you need to recognize that integrand pattern. That is the pattern for an inverse tangent. So we'd have minus 3, the 3 remains as our coefficient, You can either write it as arctangent or tangent to the -1 of x, doesn't matter, plus c. Again, take your derivative. You'll notice you get that integrand back again.